next you can see that, okay, now if you want to exit this mode, so just click on escape or just click on right button. Okay, so here it tells you that required input is still incomplete because we have not provided that what is inside this stream, what is specification of this pump. Okay, the software still doesn't know. So you can also rename this streamer. Just double click on it. You may call this 1, 2 feed or whatever you want to call this. I will leave this as S1. So double click on this stream. Okay, alternatively, okay, if you want to go back to the your flow sheet, just click on this view button and click on the flow sheet button. So we are again in the flow sheet. Alternatively, you can in this streams and S1, so you can also open this stream from here. Stream S1 and then input. So our stream has a temperature of 70 degrees C. I will write 70 here. You can change the unit from here, and the pressure is a 1 bar, right? Okay, and I know the mole flow rate. So the mole flow rate, and it is given in a mole per minute. So I will change this to mole per minute. Mole per minute. This is mole per minute, and the hexane is flowing at 100 mole per minute, and the decane is flowing. It is also flowing at 100 mole per minute. Okay. Now I want to raise the. I will again click on view and flow sheet. I want to raise the pressure from 1 bar to 5.2 bar. So double click on the pump, or you can just select the pump from here. So this will be open. Select from here. Okay, and now enter the discharge pressure. So the discharge pressure, if you know the pressure increase, so then you should select the pressure increase. If you know the pressure ratio, then you should select the pressure ratio. Or if you know that, let's suppose that this power pump is 5 kilowatt hour, so just provide the power and it will calculate the output pressure for you. So I know the discharge pressure, so discharge pressure is a 5.2 bar. Okay, and you can see again that this required input is complete. Now just click on this run button. Okay, if you click on this run button, and in the pump, go to the results. So here you can see the various results. So another question for you: to report the temperature of stream 2 pump outlet and the report the total electricity required to operate this pump. So from here you can see different results, right? And these are the results of the pump. You can see the NPSH, you can see the electricity and so on. Okay, and if you want to see the results of the streams, just click on the stream results, right? So this is stream S1, this is stream S2. So you can see that stream S1, it is 2 is going into the pump, and stream 2 it is going out from the pump, right? You can see the state, both are liquid. Here you can see the temperatures, the pressure, okay, the molar vapor friction and several other properties. You can check the mole flows in kilomole per hour. I want to see this in mole per minute, so you can actually change this mode to something else like a kilomole per minute, for example, or a mole per minute. So you can actually change the units from here. Okay, and you can see the mole friction. You can also see the mass flows and the mass friction. So let's suppose I want to just see the result of the stream number 1. So double click on stream number 1 and then click on the results. So these are the results of stream number 1. Here I want to see the stream number 2, so just select stream number 2. Another is the select the stream and press Ctrl R. So here you can see the results, right? I want to see the results of the pump, so select the pump and press Ctrl R. So these are the results of the pump. Okay, now this stream is going into the distillation column. So you know that distillation column, this is a okay, it should be available here in this column. So click on column, and here you can see lot of columns. So you can see this DSTWU. This is actually when underwood Gilliland method, shortcut distillation column. If you hover over it, it will tell you that what is this. This is another shortcut distillation column. This is red flag. This is a rigorous model for distillation. Similarly, this is the for the liquid extraction. This is the rigorous fractionation for complex columns such as crude units, and this is the shortcut distillation for the complex columns, and so on. Okay, we can actually use this column for shortcut calculation. Also, this column for shortcut calculation. However, here you shall use the red flag. Okay, you should not worry at the moment because we will explore this in much detail later on. This red flag. So select this red flag column, install it here. Okay, and click on this right to escape or to exit this mode. Okay, now you need to connect this stream with this. So if I drag this, okay, this stream is not actually connected now because you can see if I move it, so it is not connected. So when this arrow is white, that means that the stream is not connected. When it becomes black, then that means that this is connected. So how to connect this stream? Okay, first let me call this as a distillation. Let me call this just call distillation column, and now double click on this arrow and hover over this red arrow and then click, and now it is connected. Now you can see that the arrow is now black. Okay, similarly connect the top stream. This is the top stream and this is the here connect the bottom stream. You know that this is the distillation column. This distillation column has the a condenser, okay, and this distillation column has a reboiler. So the top product is connected here and the bottom product is connected here. So I will just call this T top product and I will just call this B the bottom product. Okay, so now you need to specify this column. Double click on this column, and this is the calculation type is equilibrium. Here you need to enter number of stages. We have 15 stages. Okay, please note that 15 stages is also counting the condenser and the reboiler as a stage. So actually we have 13 trays, a condenser and a reboiler, which are total 15 stages, but the number of trays are 13. And the condenser, we have a total condenser. Similarly, we have a total type of reboiler, and the valid phases are the vapor liquid. The convergence method, we shall explore this later. We have different convergence method, so leave it as standard. And now we know the reflux, the boil-off ratio and the reflux ratio. So the boil-off ratio is given as a 4.3 and the reflux ratio is 6.1, right? Still it is asking you that required input is incomplete because it doesn't know where is the feed stream coming. So click on this stream, and this feed stream which was actually S2, it is entering at stage number 7. Stage number 7 means that it is entering at tray number 6. Still the required input is incomplete, so it is asking you about the pressure. So just click on pressure and enter the pressure. Here is 5 bar. Okay, the condenser pressure is 5 bar. Now you can see it input changed, and that message no longer appear that required input is incomplete, right? So now run the simulation. Okay, just click on this home button and click on this run. Okay, you can see that the results when the simulation run without any errors. So you can see this message, this beautiful message of results available. So now I have few questions for you. Report the total flow rate of in-hexane in the distillate in kilomole per hour, and also report the total heat duty in the reboiler in a gigajoule per hour. So I will help in the second question, and you should know to answer the question number 5. So the duty of the reboiler, while click on the column, okay, from in the blocks click on the column, and now click on the reboiler. Just go to the results, right? Click on the results in the blocks, click on column, all, then click on the results. So here you can see the heat duty. This is the reboiler stage, right? So this is in the calories, so you can gigajoule per hour or some other units. And this is the top stage. You can see the temperature. You can see the heat duty of the top stage, which is actually condenser, right? Distillate rate, reflux rate, and so on, reflux ratio. And here you can see the details of the reboiler. So now I want to cool the bottom. I want to cool the bottom product to 25 degrees C. So how will I do it? Just pause the video and do it yourself. How can we do that? Just again go to this, click on view and go to the flow sheet. Okay, I want to cool this to 25 degrees C. So if you want to see the temperature, what is the temperature of this stream, and this stream, if you want to label this this flow sheet, so just click on the modify and select temperature here. So you can see that temperatures appear here, right? If you want to see the pressure, so just click on the pressure. If you want to see the mass flow rate, click on the mass flow rate. So this icon means temperature and that icon means the mass flow rate. So I want to reduce the temperature from 223 to 25 degrees. So how can I do this? Of course, we will go to the exchanger and then I will select a heater. Although I am cooling this, but there is no separate cooler block for the cooler in the ASPEN Plus. So you just select this heater, install it here, right click, call this cooler, and double click on this stream and then join it here, and then again click on this material stream and add another material stream here. Okay, please ensure that you are connecting with the red, not the blue, which is actually water or dirty water. So now double click on this block, and okay, there is no pressure drop, and we know that the outer temperature is 25 degrees C. There is no pressure drop, so I will just write 0. That means that there is no pressure drop. If I write this -1, that will mean that pressure drop is 1 bar. Okay, if I just write 1, what this will mean? This will mean that the outlet pressure is 1 bar. So we will just write 0 here. That means that there is no pressure drop, and run the simulation. Okay, and again there are some questions for you that report the heat duty required to cool this from 227 degrees C or to 25 degrees C. At how much heat we need to remove. And another is report the mole fraction of hexane in the distillate if you feed the mixture to the column above stage 3 instead of stage 7. So first answer this question and then answer this question. Here you will change the feed stage from 7 to 3. So you know how to do that, right? I will help with this question number 7. Go to the view flow sheet, select this and press Ctrl R, or you can see the results from here, cooler, and click on results. So it is asking you that you need to remove this amount of heat. If you want to see this in kilowatt, gigajoule per hour, so this is in gigajoule per hour and this is in a kilowatt, right? And you can see a negative sign here, right? That means that we are actually removing heat. If this was heater, then this would be positive. This value would be positive. So answer the second question as well. You can see the answers in the description. So in today's lesson, you have learned how to open ASPEN Plus, how to add the components, and how to set up a flow sheet. I will see you in the next lecture where we will learn how to estimate properties of flavor chemicals, a binary mixture, and multi-component mixture in ASPEN Plus. See you then.